Hello, my name is Tim Davies and welcome to our FTS online class. So we're now on to the probability reading and we're going to be learning a lot of interesting things here. So I think we're going to enjoy this reading. So let's get started. So we're first going to start off by looking at some definitions, and the first one is a random variable. Now this is an uncertain outcome or quantity. So let's say, for example, we buy a share today. 1 year from now, we don't know what that return is going to be. So that's going to be a random variable because we have an uncertain outcome or quantity. Then an outcome, this is a possible value of a random variable. So let's say 1 year from now, the return is 8%. That is going to be an outcome because it's a possible value of our random variable. And then an event, this is a specified set of outcomes of a random variable. So for example, let's say we got here a portfolio earns a return of less than 8%. Now here, we've got an infinite number of outcomes because we could get 7% here or 6% or 5% or 5.5% or 5.75%. So there we can see we have an infinite number of outcomes. Now we need to know the two defining properties of probability. So the probability of any event, which we just call E, it's between 0 and 1. So if we put the probability of the event over there in the middle, we can see it is greater than or equal to 0. And it is less than or equal to 1. So we can see that we include the equal signs over there, which means that the probability it's inclusive of 0 and inclusive of 1. So if the probability is 0, this means it definitely won't happen. And if it is 1, it definitely will happen. But in between, we have a certain probability. So let's say, for example, we flip a coin. We know that the chance of a head is going to be 0.5 or 50%. So we're measuring here the chance that a stated event will occur. So, and then the other property is that the sum of the probabilities of any set of mutually exclusive and exhaustive events, this equals 1. So the sum of the probabilities equals 1. Now, a very good question, and you might ask yourself, what does mutually exclusive and exhaustive mean? It's over here. So mutually exclusive, this is where only one event can occur at a time. So we've got the example here. Event A is that the portfolio has a return of 8%, and event B is that the portfolio earns return below 8%. So now, of course, A and B, they can't happen at the same time. So that's going to be mutually exclusive. And then exhaustive, this means the events that cover all possible outcomes. So the events A and B over here above, over here, they are not exhaustive. Why? Because, of course, we could get more than 8%. So if we now include the third event, event C, we call it, the portfolio earns a return above 8%. Now, A, B, and C, they are mutually exclusive. Why? Because they can't happen at the same time. We can't get 8%, less than 8% and above 8% at the same time. They are mutually exclusive, and they're also exhaustive because they cover all possible outcomes, because we can only get 8% or below 8 or above 8. So we are covering all possible outcomes here. So the probability of A, B, and C, that's going to be a number between 0 and 1. So for example, the probability of C, that was that we get more than 8%, that could be, say, 60% or 0.6 in decimals. But the probability, if we sum up the probability that we get 8% and we get less than 8 there and more than 8 there, that's going to give 1 because we've got all the possible outcomes over there. Good. So now we need to know a few more definitions here. And the first one is empirical probability. So this is the estimate. I beg your pardon, over here, we estimate the probability of an event from historical data as a relative frequency of occurrence. So remember relative frequency. So it's nice and easy. So we've got a little example here. Let's say we've got 35 out of 50 stocks in a small cap equity index. They have an increase in their EPS. So what is the probability of stocks in the index with an increase in EPS? We just, of course, we take 35 out of 50 of them, which is going to be 0.7 in decimals or 70%. Right, and then a priori, this is a Latin phrase. So this means this is obtained based on logical analysis. So if we look at a dice, we can say to ourselves, well, there's going to be a 1 in 6 chance that I'm going to roll a 6, for example. And then subjective, this is, of course, obtained from drawing on our own personal judgment. So I can say, well, it's my opinion that there's an 80% probability that the EPS of company A will grow by more than 25%. That is my own personal view, so that is subjective. Now, I just made a little note here that these two, the empirical and the a priori, they are, of course, are objective. Good. Now we're going on to odds for and against, and gamblers are very good at this. So let's have a look what we got here. So the probability of an event, which we call E. So the probability of event is stated as, if we want to state it as odds, what do we need to do? You need to take over here the probability that the event will occur in the numerator there. And we're going to divide that by the probability that it will not occur. So we just take 1 minus the probability that it will occur, and that will give us the probability that it will not occur. And then odds against is just the inverse of odds for. So for odds against, we've got to take the probability that it will not occur, and we're going to divide it by the probability that it will occur. So let's do this example, and it will clear everything up. So we've got the probability that South Gold dividend per share will increase. It's 33%. So what are the odds for a dividend increase? Well, all we need to do in the numerator is take the probability that the event will occur, that the dividends will increase, which is 0.33, and we're going to divide that by the probability that we will not get a dividend increase, which is going to be 1 minus our 0.33. So that's going to be then 0.33 divided by 0.67. So I just want to stop here for 1 sec. If we add the numerator there to the denominator there, we're going to get a total of 1, right? So because we've got all the possible outcomes there, and then that is going to be 0.5 in decimals. But if we put it into fractions, it's 1/2. So now we can do our odds. So the odds for the dividend increase are going to be 1 to 2, 1 to 2 over there. Or we can also use over here fractions. We can do that if we want to. Because we know that 33.33%, we know that's a third. And then we can rather use fractions if we want to. So then there, the 3 and the 3 is going to cancel, and we've got there 1 to 2, the same thing again. Right, now what about odds against? So as we said, for odds against, we're just going to take the inverse of odds for. So we're going to have in the numerator now the probability that the event will not occur this time, which we've said is already 0.67. The probability of no dividend increase is going to be 0.67. We divide that by the probability that dividends will increase, which is 0.33. And now we can see the odds against are 2 to 1. There we go. Alternatively, again, we can use the fractions if we like. So we can take, we know it's a third, 33.33% is the third over there. So we can take 1 minus a third in the numerator and divide it by the third there, the denominator. So again, there we've got the 3's cancelling. So now we've got 2 to 1, right? So the odds against the dividend increase are 2 to 1. Good. Now, if on the exam they give us the odds for a certain event are A to B, let's say they tell us they're 1 to 2 or 5 to 1 or whatever. If they give us the odds, we can then work out the probability. So what we're doing now is going the other way around. On the previous slide, we had the probability and then we worked out odds. Now we got the odds and now we're going to work out the probability. So if they give us the odds, how do we work out the probability? All we do is we take A there, whatever the A is, we'll do an example now to see, whatever A is goes in the numerator, and then we've got the sum of A and B there in the denominator. So we're going to do the same example then as we did on the previous slide. And remember the odds that they increase the dividend, remember that was 1 to 2. So this means that our A, I beg your pardon, our 1 is now A, and our 2 is now the B over there, because it's A to B. So 1 is our A and 2 is our B. So now if they want us to work out, what's the probability for a dividend increase, we just take A in the numerator there, and we divide by the sum of A and B, and that gives us our 33%, and that's working out because that was what we had on the previous slide. That's what they gave us on the previous slide they gave us that probability on the previous slide. And then what about the other way around? That if they tell us the odds that they do not increase the dividends, that give us now a 2 to 1, and they ask us now, what's the probability then of no dividend increase? So our A is now the 2 and our B is now 1. So we just take the A there in the numerator and we take the sum of A and B again in the denominator, and we get 2/3 there. Good. And again, it's tying up with what we saw on the previous slide. Fantastic. Right, so now we're going on to unconditional and conditional probabilities. So first of all, we're going to do the unconditional one, which is also called marginal probability. So this is the probability of an event regardless of the occurrence of other events, which we just denote the probability of A. So it's the probability of something happening regardless of any other news. So let's try this example here. We've got, they give us the probability that the sales of Riverside retail increases regardless of the state of the economy. So we can denote it like this: the probability just that their sales increase, we can call it the PS for short, that is going to be 55%. So that is going to be an unconditional or a marginal probability. Now we come to conditional. So what happens here? This is the probability of an event given that another event has occurred. And we denote this, the P, with a little vertical line in between the B. So when we see this little vertical line, we must always say the word given in our head. So it's the probability of A given that B has occurred. So let's try, we've got two little examples here. So the first one is the probability that the sales increase, the sales of Riverside retail increases given that there's an economic expansion. So we put here, that's the probability that the sales increase given that we've got an expansion. So we can call it PS given probability bigger part of sales given the expansion at 75%. Now we can see that this conditional probability, it's greater than the unconditional probability, which makes a lot of sense, because if we've got and the economy is doing well, we would expect now the sales to do well because we now got more information. We know the state of the economy. Over here, we didn't know the state of the economy when we did unconditional probability. So now let's try the next one. Now that we're looking at the probability that the sales increases, but now given that we got a recession, so that's, we would expect that there's going to be a lower probability in this case. So we're going to just put here the probability that the sales increase given that we've got a recession. So we can call it PS given R. The probability sales increase given we've got a recession, that's going to be 40%. That also now makes sense, because now the conditional probability is less than the unconditional. So we would expect this to be the case, because if the economy is doing poorly, then we would expect the sales, the chance that sales and increases is going to be less. Good. So now we're going on to joint probability and the multiplication rule. And so the joint probability of A and B, this means it's the probability of both of them occurring. And we denote it like this, with nothing in between. So if there's nothing in between the A and the B, we must just say the word and in our head. So here we've got an example, not an example, how it works. So it's the probability of A and B. What is it? It's the probability of A given B multiplied by the probability of B. And we call this the multiplication rule. So what we need to then, so what I always like to do is, if they want me to work out, what's the probability of A and B, I always like to write that out again on the right-hand side of the equal sign, but just put the line in between. So now I've got the probability of A given B, and then we need to multiply by the probability of the second one. Now we can rearrange this formula. So if they want us to work out what's the probability of A given B, and they give us the probability of A and B happening and the probability of just B happening, then we can work out what's the probability of A given B. So I did see one of the CFA Institute practice problems. They asked for exactly this. So you will see an example like this when you do the practice problems. Remember, we need to do our practice problems, and they give us this info here. We can just work out that, but we're going to do this example over here. So we've got the probability that the economy is in expansion. We call that PE for short. That's 60%. And the probability that this we did on the previous slide, that Riverside retail sales increase given that the economy is in expansion, that was 75%. Now they want us to work out what is the joint probability that their sales increase and the economy is in expansion. So that's going to be P, the probability of S and E happening is the probability of S given E multiplied by the probability of E, the second one. So there we've got our numbers there. The probability of the sales increase given the economy is expansion, that's 75% there. And we just got to multiply that by the probability of the economy is in expansion. That's going to be 0.6. So we've got a 45% of both S and E happening. And I just made a little note down here that the probability of A and B happening is exactly the same as the probability of B and A happening. So if we want to work out what's the probability of B and A happening, all we've got to do is take the probability of B given A multiplied by the probability of A. So what we need to just remember is when we practice our examples and our questions, we will use the relative formula based upon what information we're given. So all we need to do here is practice, because the formulas are not long or anything. We just got to do our practice, and we're going to be just fine over here. Good. And then the last thing we need to do in this class is look at the probability that A or B occurs, and here we use the addition rule. So the probability that A or B occurs, which means the probability that at least one of the two occurs, we denote it like this. It's the probability that A or B happens. It's just the probability that A, we just take that probability and we add the probability of B. And what do we do now here? We subtract their joint probability over there. And this is what we call the addition rule. And the or in this instance, it is inclusive, which means that either A or B occurs, or both of them can occur. Right, so over here we've got, they call this the Venn diagram, which is nice to see this in the diagram, because here we've got probability A happens, and there we've got probability that B happens, and over here we've got the joint probability. So this we got to take this out, because if we don't take this out, we're going to double count. So that's why we take it out over there. So let's try this example here. So the probability the economy is in expansion, they tell us is 60%. And the probability that the sales increase, that is 55%. So now the joint probability we worked out on the previous slide, that was the probability the economy is in expansion and their sales increase. That was the 45% from the previous class. So now we can work out the probability that the economy is in expansion or that their sales increase. So we got to take the probability that the economy is in expansion over there, and we add on to that the probability that the sales increase, which was the 55% there, and we take out that joint probability over there. So we're going to take that out over there, and we come out at 0.7 or 70%. Good. So that's the end then of that class. And as I was saying, all we need to do over here, is practice our examples and our practice problems, and we're going to be just fine here. And we'll see you guys in the next class. Hello, it's Tim here again. I hope you enjoyed the class and found it beneficial. We have some classes available for free on YouTube, but we have classes for the entire curriculum. The classes that are not on YouTube can be purchased from us. If you'd like to purchase the classes, please contact us for the pricing, and I've put our contact details over here. You can purchase all the classes or certain readings that you would like. When you purchase the classes, we provide you with the slides and our notes. I've assisted hundreds of candidates pass CFA exams, and I look forward to also helping you through the CFA program. I've put in 2 testimonials in the slide over here, and we also have a testimonials page on our website that you can review. I look forward to seeing you soon, and all the best.